right, so now we're going to continue our pH lecture, and we're going to talk about, well, what happens if the changes in pH are so drastic that the buffer system is unable to keep up with it. Okay, so if it goes too far in one way or another, you can get a pH disorder. So a pH disorder is, there's two broad categories, and then each broad category has a subcategory. Okay, so remember that the range is between 7.35 to 7.45. You do not need to memorize those numbers, but I do want you to kind of have it in the back of your mind. But if it goes below that, and again, a pH below 7.35 means there's extra hydrogen ions, more hydrogen ions than normal. That's going to be classified collectively as acidosis. But then acidosis has two subcategories under that, which are respiratory acidosis and metabolic acidosis. So you'll notice that the second word in the disorder relates to whether or not it's too acidic or too basic, and then the first word in the disorder relates to the cause of the pH change. Okay? So for respiratory acidosis, what that means is it's too acidic, too much hydrogen ions, because there's too much carbon dioxide. And that must mean that it's related to the respiratory system. So any kind of disorder that's related to, reduced rate or depth or anything related to breathing, all of that is going to fall into respiratory acidosis, whereas metabolic acidosis has to do with buildup of metabolic activities. So that is pretty much anything else, right? Any other type of acids that are created, that's all metabolic acidosis. Okay, and then if it is greater than 7.45, okay, so again, greater than 7.45 means that it has fewer hydrogen ions than normal. That's going to be classified as alkalosis, and the two subcategories for that are respiratory alkalosis and metabolic alkalosis. So again, respiratory means that it has something to do with breathing, not breathing enough, or problem with breathing, or something related to ventilation. And what happens if you don't have enough hydrogen ions, that must mean that you don't have enough carbon dioxide. And so that's going to happen if you have hyperventilation. You're breathing too fast. You're exhaling too much carbon dioxide. Okay, so if you're exhaling too much carbon dioxide, that means you'll have too little carbon dioxide left in the blood. That will mean too little hydrogen ions, and that will make it so that it's more alkaline, more basic, and that'll increase the pH. And again, metabolic, if that means pretty much all the other causes. Okay, so I kind of created a little decision-making chart for you here. So if it is too low, that is an acidosis, and then you need to decide, is it respiratory or metabolic? And so you'll look at the cause. If it's anything to do with breathing or respiratory system or lungs or anything related to that, that will be respiratory acidosis. If it's any other cause, right? So you don't need to memorize anything specific. Anything not related to breathing, all lumped together as metabolic acidosis. And then the same with alkalosis. Alkalosis means that it is too basic, above 7.45. Anything to do with breathing, respiratory alkalosis. Anything else, that would be metabolic alkalosis. Okay, so one of the things that you will be asked to do is, if I describe a situation, you'll have to kind of diagnose it. And when I diagnose it, you want one of these four categories. Okay, so let's talk about, well, how do you fix it, right? So one of the things is when the pH starts to change, then you'll have the respiratory system trying to fix it. And then if that doesn't work, then the metabolic system is trying to fix it. Okay, so the buffer system sort of kind of immediately, the respiratory system is the moderate, and then the renal system is sort of the slow, like, bringing in the big guns. Okay, so let's look at this. If the respiratory system is about breathing, what specifically does it have control over that affects pH? as we've just seen, carbon dioxide affects pH, and that's what the respiratory system has control over. And so what happens is when you have changes in carbon dioxide, those changes in carbon dioxide are going to be sensed by chemoreceptors that are found in the major arteries, the aorta and the common carotid artery. That's going to send that information to the respiratory centers in the brainstem, specifically the medulla oblongata and the pons, so in those brainstem, and they go to the rhythmacy centers, and the rhythmacy centers will set the rate of ventilation, how quickly you are breathing, okay? So if you have an accumulation of acids and it becomes too acidic, okay, so you have an increase there, what's going to happen is you're going to start, that means, so if it's too acidic, you have too much carbon dioxide, and you're going to have to breathe faster to get rid of the carbon dioxide. Okay, so if it's too acidic, you're going to have to increase the rate. Okay, so the key to really mastering this concept is to really have an understanding of the relationship between carbon dioxide and hydrogen ions. They are direct. So an increase in carbon dioxide means an increase in hydrogen ions, and an increase in hydrogen ions means and a decrease in carbon dioxide means a decrease in hydrogen ions, right? They're the same, okay? So if you're too basic, that means you don't have enough hydrogen ions. How do you increase hydrogen ions but changing the carbon dioxide? That means you need to keep more carbon dioxide. So you need to increase the concentration of carbon dioxide, and you do that by breathing slower. Okay, so you'll decrease the rate of carbon dioxide. Okay, so again, if you understand the relationship between carbon dioxide and hydrogen ions, this should be logical. You really shouldn't have to memorize this. Okay, so let's look at a real life example of what happens. So when you begin exercising, right, all of those skeletal muscles are really metabolically active. You're going to need a large supply of ATP, so you're doing a lot of cellular respiration. All that cellular respiration is going to increase the concentration of carbon dioxide. Okay, so you're going to have an increase in the concentration of carbon dioxide as the cells are spewing out more of those carbon dioxide. But if you look at these graphs right here, you don't really have much of a sharp increase. Okay, there's a little bit of fluctuation at first, but you're not going to have this big increase in carbon dioxide. Why not? Okay, and the reason is when you start exercising, what happens to your respiratory rate? You start breathing deeper and faster, and when you breathe deeper and faster, you're going to get rid of the carbon dioxide, and because you're getting rid of the carbon dioxide more, so more carbon dioxide will leave, all that extra high carbon dioxide is going to go out, and when you decrease the concentration of, so when you prevent changes in the levels of concentration of carbon dioxide, you're also going to prevent changes in pH. Okay, so both carbon dioxide and pH are held fairly consistent, even though you're very metabolically active, and it's because of the respiratory compensation that increase the rate and depth of your respiratory, of your ventilation. Okay, again, this isn't really news to you. You know you breathe fast when you exercise, right? So you really just it's just really about putting the ideas together. Okay, renal compensation. Remember, renal means the kidneys, and so what we're looking at is what's happening in those nephrons when you create the urine. So if you think back to renal absorption, renal secretion, all of those things about creating the urine, what does the renal system have control over that might affect pH? Think about it. It gets to decide what is reabsorbed back into the body and what is not. So remember that anything that is in the tubes, in the renal tubes, those will be secreted and you'll get rid of it. And anything that is reabsorbed into the bloodstream, you get to keep. Okay, so in the renal system, it can adjust pH by directly adjusting the amount of hydrogen ions that it excretes or keeps or reabsorbs, and the amount of bicarbonate ions that it excretes or reabsorbs. Okay, so if you have acidosis, and it does not matter if it's respiratory acidosis or metabolic acidosis, the compensation mechanisms would be exactly the same. So if you have acidosis, that just means that you have too much hydrogen ions. So how do you fix it? You get rid of hydrogen ions. Okay, so too much acid, too many hydrogen ions, you need to get rid of some, so you'll increase the secretion of the hydrogen ions. Okay, so you secrete more hydrogen ions. Anytime anything that's in those tubules will be secreted and peed out. Okay, whereas you'll reabsorb more of the bicarbonate. Okay, because remember, bicarbonate is a base, so that'll help offset some of the changes in pH. Okay, so again, not rocket sciences. You just follow the logic here. If you have alkalosis, again, metabolic or respiratory, same difference, same compensation. What's going to happen is you don't have enough hydrogen ions. You're too basic because you need more hydrogen ions. And the way that you get more hydrogen ions is to reabsorb more hydrogen ions. So you'll just reduce the secretion of hydrogen ions, therefore increasing the reabsorption of hydrogen ions. And then at the same time, you'll secrete some of the more of that bicarbonate because the bicarbonate is a base. And voila, that helps fix the pH changes. Okay, so do not try to just brute force memorize this. That's a great way to get yourself confused. Just logic your way through it. If you don't have enough hydrogen ions, you keep more hydrogen ions. If you have too many hydrogen ions, you get rid of more hydrogen ions. Okay, so memorization is not how you get through this kind of information. Okay, so on Canvas, I put a pH review activity. I strongly recommend that you print it out, you try to go through it without looking at the key, and then look at the key. Okay, good luck. Email me if you have questions.